Good afternoon, everybody. My name is Marco Russo, and I'm here today to talk about Power Pivot. But this session has a particular focus, which is budgeting with Power Pivot. Before introducing the session to you, I would like to do a quick poll just to understand the audience I have today. How many of you use Excel? Nice. So you are awake. Good. How many of you use Power Pivot? How many of you know DAX? Wow, nice. It would be funny. How many of you use Power Query? Great. So this would be a nice session. So, okay, please silence the cell phones. Because in the last few years, I worked a lot in Power Pivot and DAX. I wrote with Alberto Ferrari and also Chris Webb a few books about analysis services, which is the technology that is behind and inside Power Pivot. We recently wrote a book about DAX pattern, and I will come back to this in a minute. And we are writing a new book about DAX that will be ready end of this summer. So I have much experience in business intelligence. You can find on our website many articles, content, and so on. And the idea of this session is the following. Imagine you have, and we will see an example in a few minutes, imagine you have data about sales. Imagine you have a budget for the new year, and now you want to mix the budget, you want to display, you want to create a report that compares the budget with the actual sales that you have. You know, pretty much simple in theory, but usually you don't have the data that will be perfect to do all the comparison that you want. So the idea of this session is looking at how you prepare the data in order to solve a number of common issues that you have in this scenario that I'm going to show now. During this session, we will see and we will make a few considerations about the data modeling in Power Pivot. We will see how to solve certain problems in DAX, how to solve other problems in Power Query, and also how to use a certain feature of Excel writing DAX query. The session is not necessarily the right thing to create the budgeting system. I will do certain operations using different technologies because I want to show you how to look at the problem from different point of views. Then maybe that in your particular case, you will be able to solve your specific problem by using just one of the technologies that I will show you today. So remember, I'm not showing you the perfect solution. I'm showing you a number of solutions for the same problem, fundamentally. So with this in mind, for those of you that don't have a deep knowledge in DAX, don't worry. Look at the session thinking about, okay, this is possible. I can do this without using other tools, without using SQL, for example. For those of you that already know Power Pivot and DAX, look at what I do to solve certain problems, and if you have any doubt, raise your hand, stop me at any moment and ask your question. I prefer to be stopped, to be interrupted. No problem, I will handle that because in this way the session is more interactive. So, first demo. What is the scenario that we face? And the idea is pretty much simple. You know, AdventureWorks, Contoso, we have sales of products over time. We sold these products in different stores across different countries. We have a hierarchy of products. We have category, subcategory, but we also have other attributes like color, like brand. We have many information. And we ask to several parts of our company to prepare the budget of sales for the next year. So in some way, we create this table, this forecast table, which is fundamentally our budget. So we suppose to sell for every brand in every country a certain amount of dollar. However, since we know that, it's a forecast, it could be good, it could be bad, we ask to prepare the budget considering different scenarios. So we have different, in this case, 4 scenarios, starting from a pessimistic one to a very optimistic one. So we have different forecast models that we will use in this analysis. Now, if you think for a moment at the problem, if I have this table is very simple, has only 4 columns. But my data model behind the pivot table here, I can navigate into this pivot table looking at data for different tables, like for example the store, we have continent, country, we also have the city. But if we look at the product, we have the product category, we have the product name, we have the color, we have the class, the brand. Now, the brand is one of the dimensions, one of the attributes for which we ask to prepare the budget. But then we would like to see a budget for the color, maybe evaluated in some way. So we have a number of things to think about. And another thing, the budget is defined at the year level. But usually you look at sales month by month, and you may want to allocate the budget month by month. So this is the problem. So first of all, we have to start from this data model, which is currently only the data model of our sales. Here we have the store table, the sales table, the product table, the subcategory and category table, and we have a day table, and another table which is the scenario, pessimistic, optimistic, moderate, and so on. We don't have the forecast here, we still have to import data from our model. Now, the first problem is we have to do some allocation. And as I said, I will show you how to do this, how to solve this problem in different ways. What I'm going to show is a more elaborate version of this pattern. This is one of the patterns that we will see today, which is probably the one that is based only on DAX. I will show you something also based on Power Query now. And in the website, daxpatterns.com, you will find this article. So you will find here other examples, other formulas. So don't spend time copying the DAX formula. You will find this in this article, okay? And let's start considering one of the issues that we have to solve. This is our budget, and we want to allocate the budget. Now we have country category, but it could be country brand like we have in our budget. Starting from the sales that are defined by 1 year, I want to allocate data month by month, or maybe day by day. Now, the problem is that how we can do this allocation. This is a business question. I cannot answer. I can say, I ask to the manager, I ask to the people who know the data what they want to do. Do you want to allocate the budget by dividing the number by 12? Easy. Or dividing the number by the sales that you made 1 or 2 or 3 years ago, I don't know. So once you find what is the right thing to do, you start implementing something. So I asked to the people who are in charge of this analysis, and they say, okay, we want to allocate the data, the budget data, considering the actual sales we made in 2009. So the year 2009 represents our benchmark, our reference for the allocation. Good. So at this point, I start to consider which option I have. And in general, we can split our possible solution in two different areas. One is I do a static reallocation, which means I allocate my budget in a static way. So I know that I want to get this number and split this number at a certain granularity level. Or I may want to do a dynamic reallocation, which means that instead of calculating all the values in advance at the right granularity, depending on the pivot table settings, depending on the pivot table filters, I will do the allocation dynamically. The result could be the same, and I'm not here to say what is better. It depends. The static reallocation could be the right choice when the algorithm that you are going to implement is very complex because of performance. The dynamic reallocation could be very good because it is less expensive in terms of memory, but it could be more expensive at query time. We will see both, so you can choose. So let's start with the static reallocation, and in this case we will use Power Query. But we will not use just Power Query, we will use also DAX, because the first thing that we have to do is think about this. We have to get the reference for the allocation. And in order to get the reference for the allocation, we may create a pivot table where we put data divided by, for example, the store, the product category, and the date. The product category, sorry, the product category I said. The store country, the product brand, which are the two dimensions we have here, because I want to know what was the previous, the correspondent amount of sales in 2009 for this granularity and for the granularity at which I want to allocate data. So for example, each product and so on. So the first thing that I do is I want to create a table that will help me in doing the allocation. And one thing that I can do is because I need a table, I need just a table. I don't need a pivot table, I need a table. And I want to be able to import this table into the data model, which is in Power Pivot. So if I create a pivot table, I cannot get the result of a pivot table and I want to import the result of the pivot table within the same Power Pivot model. I can use another technique, which is the following. As you know, DAX is also a query language, which means that you can write a query in DAX just like you write a query in SQL. DAX Studio is a free add-in that you can download from daxstudio.codeblex.com, which can be used as an add-in in Excel and allows you to connect to the Power Pivot model and write your DAX expression, your DAX query, in a window here and look at the result here. So for example, if I write here, evaluate, for example, product, and I click run, I see in my result window the result of this query. So what I want to do, I want to write a query here that I will use in some way in my Power Pivot model. Okay, so at this point, if you don't know how to write the query, you will find some documentation on the web, in articles, in the documentation from Microsoft. So if you already know DAX, you probably will understand what I'm going to do. So the first thing that I do, I want to get the granularity that I need from my data model. There is a function in DAX to do that, which is summarize. And this, oh, I forgot one thing, otherwise that DAX formatter will not work, sorry. If I use summarize, I can put, for example, here the sales table. So I want to group my data of the sales by the country, so store country, if I remember this, or as you see, you can use the metadata that you have on the left pane. For example, I need the product category name here, and I need also the month number, because my goal is I want to allocate the granularity of the static allocation has to be the category, the month, and the country. So this is the allocation that I want to do. So I get the date, month number here, and I close the parentheses. Now, if I run the query here, what I see in the result window below here is a list of country, category, month number, which is the granularity I need for my calculation. By using this button, you can also format the query in a nice way. This is using another service on the web, DAX Formatter, that help you getting something more understandable. Now, once I have the granularity, I need to get the value of the sales that I had in 2009. But I need data in 2009, but I will solve this problem in a moment. So the first thing that I do, I want to add a column here because I need an amount of sales, which is the measure sales amount that I have here. So at this point, I can run the query again and I see, wow, add columns, yes, that I have my data with sales. So this is the amount of sales of all the years. I want to get only 2009 because I said my benchmark has to be referenced, has to reference the 2009. So I wrap this into calculate table, sorry for the smaller font, and I write here the condition that will be that the calendar year has to be equal to CY 2009. I don't write 2009 because this is the content of my calendar year here. I have a label that has a string, so I define the string in this way. Again, I want to format this in a nicer way so it makes the calculation easier to understand. And I run the query again. Up to now, I always display the data in my output window here. So I will have to do something with this query, but I will go there in a minute. At this point, I still have the need of evaluating what? I need to know what is the ratio between the number that I see there and the total of all the months and all the categories, because I want to allocate the number for each month and each category. I start from the product brand, and this has to be split across these different numbers. And I can evaluate this percentage by adding another column here that I will call percentage, and this will be the result of a divide statement, because I have to divide the sales amount that I have here by the total of the same calculation, sales amount, for all the months and all the categories of the same country. And the country will be the join between the two tables. So I want to calculate this, saying, well, give me all the product category and all the month number. Fundamentally, this is the total of all the months and all the categories. Let me see if I did everything correct. I can format the query again, so I will see this in a more indented way. Unfortunately, if I reduce the screen size, the font size, it is unreadable. But now I see here a percentage. What is this percentage? This is exactly the allocation factor that I have to apply to the corresponding value of the country, of the budget for that country, so that I will allocate the number of the brand for that category, that month number in the 2010. Now, what I have to import this table in my data model. How can I do that? And here is the trick. In Excel 2013, you can go in existing connections and you can import a table which is a table that you already have in the data model. No matter what, if you go in the tables section here, you can choose one of the tables that I already have in the data model. Doesn't matter which one. For example, I get the product category. And I specify that I want to import the table, just the table here. Now, I created a table in Excel that reads the entire content of a table in the Power Pivot data model. in reality, you can change the content of this table by changing the DAX query that you are executing against your Power Pivot data model. And here, you can specify a DAX query. So if I write evaluate and the name of the table, this is exactly the same result. Evaluate the name of the table will return the same product category. Oops, I made something wrong, sorry. I do product category, sorry, I had to write this one. And I obtain exactly the same result. But now I can copy my evaluate statement and I can put the DAX code here, because in this way I have this result in an Excel table, which is nice because now I can use this, this table in my data model. And this starts to be interesting because now I can say, well, this is my forecast table. So I give a name to this table, forecast. And the important thing is, if I change something in the data, when I click refresh, this is updated. I'm not copying data. I copied a query, and this query can be executed at any time with the current data that I have in my data model. So the next step is I want to multiply the value that I find here, this percentage that I could display with a percentage, maybe with some decimal number. I want to multiply this percentage by the value that I have here in forecast. So I will get the value of this row, and I will join this row with all the months and all the product categories that I have in the other table so that I can do the allocation. Nice. How can I do that? Here we start using another tool, which is Power Query. Power Query allows me to use the data that I have in Excel or in my data model to create a query that generates other data that I can put in my data model. So this is another tool that we have. How can we use this tool? So first of all, I say I want to get data from this table in Excel. This is the table that I called forecast by brand. So when I click Power Query from table, I'm just defining a query definition in Power Query that just get this table from Excel. Okay, this is forecast by brand. I don't change anything here, and I choose to create just the query. So I don't materialize the result of this query. This is just a logical definition of this table. And I click load. At this point, I just have a definition of a query that is just a select star from this table. I do the same also for my, sorry, this is allocation, not forecast. This is allocation. I do this for my allocation table. So I click my Power Query from table here, and I do the same. So load to, only create connection, load, and this is allocation. At this point, I have the two tables that are two entities in Power Query, and in Power Query you can combine, you can join the two tables by using the merge function. So what I want to do, I want to start from my forecast by brand table, and I want to join this table by using my allocation table. And the column that defines the join is the country. Once I do that, I already see here that he is doing the matching between 1496 rows. When I click OK, I have a query in Power Query that shows me the result. And for each row of the original table, I have a corresponding table that is the result of the rows that have the same country in the other table. Now, what I want to do here is expanding this, including only a few columns, which are, let me check if I do the right thing, I have to include the category, the percentage, and the month number, because I already have the country in my table. Once I do this expand table, I obtain a few other columns. So you see that I have, I have my percentage here, I have my forecast, and as you see, the same number forecast is repeated for every row, because for every row, I'm multiplying this row for all the combination that I have there. And what I will do, I will multiply the forecast for the percentage, creating a new column, which is the result of the multiplication made row by row. I can do this by doing a new custom column, which is simply the multiplication of forecast multiplied by the percentage. I call this forecast allocated, and I click OK. And I see this number. This is the number that corresponds to the budget for this month, this brand, in this country, for this scenario, blah, blah, blah. Okay, so at this point, I say, well, in reality, once I did my forecast, I want to remove this initial column because I no longer need this one. I want to rename this column to just forecast because fundamentally, this is my forecast now. And I can also say, well, I could call this maybe budget. No, but I can keep this one. One thing that I suggest you to do, if you use Power Query with Power Pivot, please remember to fix the right data type in Power Query before importing the data in Power Pivot, because in this way you will be able to change your query after you imported the query in Power Pivot without losing the connection. Don't change the data type in Power Pivot for data that you import from Power Query. So here I say, well, these are decimal numbers. This is an integer number, and these other columns are just text. In this way, I fix the data type, and when I will import data in Power Pivot, I'm sure that the data type will not change just because I have different data in my data model. I call this table my my budget table or my forecast, but I can use forecast, okay? And let's call this budget, it's better. I call this budget, and I say, well, this time I want to add this table to the data model. So the result of this table, of this query, will be imported in my Power Pivot data model. At this point, I did the static allocation of my budget, but I still have a problem. Now, in my Power Pivot data model, I have a table, but this table is not connected with the other tables in my data model. Okay, let's see if I can create the connections. For example, my budget has a definition of a scenario. If you remember, we had several definitions of scenarios, and I have a table scenario, so I can create this relationship so that I will be able to select one scenario in my pivot table. I can try to create the connection with the category, because the category that I have here is the same name that I have here. So if I create the connection, since there is only one row for every category in this table, the connection is possible. However, I cannot create a connection by using the brand. Why? Because I have several products with the same brand. And I have several days with the same month and year. I have several stores for the same country. Now, for the time, I can do one solution. For the time, I can do something like, for example, okay, I have the data, the budget defined for a month. I may create a day that make me able to connect the budget to one day in the right month. It's not the perfect solution, however, but I can start in this way. So I can create here equal date, a function that says, okay, this is the let's say 2010, because I want to allocate the budget in 2010, or I may write just 2009, for example. So I will be able to compare this with the same year when I will do the pivot table. I can specify the month number, and in this case I specify budget month number, and I put this in the first day of the month. It's not the perfect solution because when you drill down the data, you will see the budget allocated in a single day. But okay, let's start solving the problem in this way. So this is my date. I can change the display format here, and I can go in my data model, and finally I can use the date here, and I can connect the date to the date here. Done. You see the connection. At this point, I want to hide these columns because I want to avoid the user to be confused by the name of columns that exist also in other tables. And I want to create here in the budget table a budget measure that is just the sum. Budget is equal to the sum of budget forecast. I specify this as a currency, as a display format. And finally, I can go back to my report. You remember my report, or I can create a new pivot table, much better, in which I can say, okay, let me see what is the value of sales amount, what is the value of the budget for a particular scenario. So I put the scenario here, and I choose, for example, the optimistic one, and I want to display this data by date and calendar here. So as you see, I have my budget allocated in 2009, which is correct. And I have my budget allocated by month, but if I go at the day level, I have the entire budget in one day. Somebody say, okay, but we will always see the data at the month level. Okay, it's okay. We can skip the problem here, but if you try to look at the data for other dimensions, for example, imagine that you put here the product category. If you put the product category, we can compare the budget and the sales amount because we actually have a division by product category. But if we try to put the product color, for example, what happened here, this is the problem. We have a division of the budget by product category, by brand, product brand, but we don't have a division of the budget, split of the budget by color. So at this point, I have a problem. How can I avoid my user to be confused looking at a number that is not correct? So the first thing that we do at this point is, okay, if you go at a granularity level where the budget does not have any meaning, hide this number. Put blank. I prefer to see blank instead of seeing a number that is clearly wrong. So how can we identify that we are browsing at a level, at a granularity level that is not correct? And this is an interesting point. Because I can use different techniques in DAX. One technique is using a few functions, a few DAX functions like isFiltered, isCrossFiltered, but in particular isFiltered, which returns true or false, 1 or 0, depending if a particular column is part of the selection. But this is boring because you have to check every single column that the user could select. And when you add a new column in the data model, you have to change your formulas. So we try to look at the problem at a different perspective. Think for a moment what I'm doing now. I have a group of products in every row. And the group of products is defined by the selection of product category and product color. Now, if I look at the value of sales, I see a number. I don't understand what is this number, but think for a moment to do another stuff, which is I can create here, what is happening here? Okay, I can create here a number of, let me see, products equal to count rows, and I want to count the rows of the product table. Okay, so let me call this products. And this number will represent the number of products that I have. I can do another calculation, which is the number of products that I have at the granularity of the budget. What does it mean? I define the budget at a particular granularity level. You remember, we define the budget at the brand and category level for the products. So if I calculate the number of products, so I repeat the same function, and I say, okay, remove removes all the filters in the products table, and just apply the same filter that are the current selection over product category and brand. You can do this in DAX by using the values function. Values returns the current list of selected values by the user for a particular column, for example. The column is product brand, and the other column is product category. And what happened at this point? It's easier if I go back to the pivot table and I put these two measures here. So I defined products and products budget. Now, if you look at the numbers, okay, forget my DAX formula. What is clear here? When the products and the products budget have the same value, I have a granularity that is compatible. I can show the number. But if the two numbers are different, the number that I have in the budget is considering a higher number of products than what I actually selected in my pivot table, so the number of the budget is not actually good. I want to hide this number. In order to do that, I can just write another measure. Let's say, is valid budget? Well, if products, the measure products is equal to products budget, yes. And I show you this in the pivot table. I'm showing you this step by step because I want to transfer you the methodology I used to create a number of measures that work together. Now, if I use this condition, is valid budget, in an if statement, I can wrap my budget into a condition that says, okay, I will show you the budget only if is valid budget is true. Otherwise, I will show blank. Okay, let's do that. So I can go here in my manage window and I can say, okay, my budget is now if is valid budget, then do this. Otherwise, blank. So this is the formula that I'm going to write. I go back to my pivot table, and as you see now, okay, I have a small issue here, which is this one. I also have to check that there is at least one one product active in the current selection. So, and products greater than 0. This could be the solution for my measure. Now, if I look at the data at a compatible level, I can see the data. Okay, this solved the problem for the products. But now think about another problem, which is I have my data that is allocated in a static way at a certain granularity. I can hide this granularity, but I would like to show the number also when I go down in a more dynamic way. So what we did until now, and let me go back for a second to the slide, what we did until now is, okay, we can allocate the data in this way, in a static way. We can hide the data because we did a static allocation. If we want to go further, we can either create a larger table with a more granular allocation, or we can transfer the problem to the to the dynamic one. And at this point, I have to solve the problem of the relationship. Because think about the problem. Up to now, I just created a workaround. The workaround is the problem that I'm not able to define a relationship between store and budget. If I select a store, a city, I'm selecting a country, but I'm selecting a small fraction of the country. Now I can actually try to create the connection, because now I have a problem. My current model does not work well if I include the country. So if I put here the country, store, country, what is the problem? The problem is that, okay, my selection here works with the products, but the biggest issue is that the budget is always the same. Why the budget is always the same? Because I don't have any relationship between the store table and the budget table. So in order to fix this, I have to apply a filter that simulate a relationship. What does it mean? The physical relationship in a data model simply transfer a filter from one table to another. If I don't have a relationship between two tables, I can create the same effect by applying a filter to a measure. How can you apply a filter to a measure? By writing calculate in DAX. So my budget definition here, let me start formatting this in a better way. So what I want to do, I want to transform this sum into a calculate that applies some particular filter. And this filter will work in this way. So I want to calculate the same amount here, and I will close the calculate here. And let's consider the store. I want to transfer the country selection into the budget table. So what I want to filter is the value of the store, of the budget, country. Sometimes IntelliSense doesn't work, you know. Okay. Now, the filter iterates all the values of the country column in the budget table. And for each of these values, I have to check whether the current selection in the pivot table includes that particular country or not. There is a function in DAX that is called contains, which allows you to iterate another table, like for example, the list of values that the user currently selected in the store table, store country. And for each of these values, I will check whether the current value of the store country corresponds to the budget country. In this case, it's like having two nested loops that work together. So this is a pattern that is described in the article that I shown you before, and also in another article that fundamentally transfer what we call a virtual relationship. A virtual relationship is you have two tables, you have a column that is identical in the two tables, you always use this pattern. You filter the column in the destination table, imagine you have one-to-many, so the fact table is filtered in the filter, and the contains iterated the other column, and finding the match between the two. So this is the idea of the pattern. Once I do that, and I click OK, what happened to my pivot table? Magically, I have my country working. However, at this point, if I put the city, I have a problem. Because if I put the city always has the same country, but the number here is repeated. What we have to do, we repeat exactly the same pattern that we used for the products, but this time for the stores. So we will create here, in my isValidBudget, I can do AND. I write a single formula, just because otherwise I will not have time. And I can write the count rows of the store table has to be equal to the calculate count rows of the store, where I remove all the filter from the store, or I can use all except store, comma, store country. Okay? this is another technique. I can say, okay, give me how many stores you have here, how many stores you have, considering removing all the filters but the country. If the number is the same, you are at the country. You don't have any nested filter. And of course, when you have a city that is the only city in the country, this technique works. But after all, you can use the budget in that case because you have only one city. Why not? So in this way, I fixed the problem. I can repeat the same for any other dimension I have. The last thing that I have to do is, okay, we solved the relationship problem now. So we created the virtual relationship, and now we want to allocate the budget by city or by product. So instead of looking at this blank value, I want to obtain an allocation. What we have to do, we have to define what is the allocation algorithm. And for example, I may do a very simple thing. Think about this. I have 1 year, 2009, and I know that in this value, it could be 1 or 2 years ago, I had this particular split of the value in Australia. It was split in this way between the cities. I can say, let's assume that we will do the same split. Let's assume that the two cities will have, because they have the same population and blah, 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 they will do the same allocation. So I want to use the previous sales that I had 1 or 2 years ago as the allocation factor for the budget that I have now. So in order to do that, I have to create two measures where I say, okay, let's see sales in 2009 is equal to sales amount with a calculate where I filter by date calendar year equal to CY 2009. And this number will be the number of the sales in 2009. It could be another year, just an example. Then I do what? So if this is the value for the current granularity, I have to create another measure that provides me the value for the budget granularity level. What is the budget granularity level? If I'm at the city level, I want to see the value at the country level. And I have to apply this for all the dimensions that are involved in my data model. So what I do here, I create another measure that is sales 2009 budget, which means at the budget level, which is a calculate of the previous sales 2009. So I don't have to repeat the filter by year. And at this point, I do this technique. When you want to apply the granularity, you fundamentally remove the filter for a table, like for example, like I did before, all except the table is a store, and you keep a store country. Now for the store, this is okay, but we also had the products, if you remember. For the products, I have to do this other thing. If you remember, the product has a product subcategory, product category. When you have a snowflake structure, it is better, it is simpler if you, instead of using all except, you use this other technique that is equivalent but can work also with nested relationships, which is you remove the filter from the product and you reapply the filter, because when you remove from the product, you also remove from the product subcategory and the product category, because you have many-to-one relationships. At this point, I can write values of a product. You remember, I have the brand and I have the product category. These are the two granularities that I have. So in this way, I say, okay, remove the filter from the product and apply the list of brands and the list of categories that I have in the current pivot table. The result of this filter is that my sales in 2009 budget is the value at the granularity level where I have the budget definition. And the division between the two is my allocation factor. So if I write, let's see this here, because it's easier if we look at the numbers. Let me remove this. So if I include here my sales 2009 and 2009 budget, you can see here that this number is exactly the number that you have here, but you repeat this number for every selection. So if I simply divide sales 2009 by sales 2009 budget, I will obtain an allocation factor. So I do here, allocation factor is equal to divide of sales 2009 and the sales 2009 budget. I can format this as a percentage because fundamentally the allocation factor is a percentage, and so I can include this here. Okay, nice. If you look at the, let me put this allocation factor here at the beginning. What I'm doing, I'm saying Sydney is 66% of Australia. I have to do this allocation. And the nice thing is that this formula works not only for the city, but for any column you have in the store table. So instead of city, you want to use state, no problem. It will work. Look at Canada, for example. Okay? Yes, you have to understand the data model, you have to understand this stuff, but once you do that, it always works, no matter what selection you make. Final step, we want to obtain this budget value correctly allocated here. These blank cells must contain the allocated factor. So what we have to do now, we go back here, and my budget now has, instead of blank, I can completely remove this if statement, because what I want to do now is multiply this number by the allocation factor. So I go back here, and here we go. We have the number here. So in this way, I started from a data model that were completely disconnected, and by using different techniques, I obtained something that can be compared. Part of the allocation was a static allocation, part of the allocation was a dynamic allocation. In this case, based on the sales of the previous year. So, what you have to consider after this session is probably I went too fast to explain in every detail every measure I wrote, I know. But you have seen that I didn't write so many measures. So first, you can do this stuff in a model. Yes, you have to study DAX or you have to copy the formula from an article, but the first thing is to realize that you can implement complex calculations also in a data model. Then, of course, the Power Query allocation was simpler because you can see step by step. If you want to implement the dynamic allocation, try to do one step at a time and always check if the numbers are correct in the pivot table, like I tried to show you step by step. And DAX is very powerful for this type of calculation. Doing this in Excel is possible, yes, but usually for a certain allocation. You decide you want to allocate by this and this, and you do this stuff in a very static way. The beautiful of DAX, it allows you to do this in a completely dynamic way, which can be useful if you have a more complex data model where you want to use this stuff. So, questions? Sorry, can you repeat? Okay, I repeat the question for the audience. The question is, what is the difference? I use it here. Oops, sorry. I used these two functions, right? All and all except. So all removes all the filters from a table or from a column. It means that if you selected a filter or you put the product name in the rows of the pivot table, the cell that contains the measure in DAX ignore that filter. When you write all except, this one, you initially remove all the filters from one table, but you say remove the filter from all the columns of this table, but country. So any filter over country is still there. Any other columns, remove the filter. The advantage of this, I don't have to worry about the fact that the user will add other columns to the stored table. You may add tomorrow the real estate, the square meters or the square foot of a shop in another column. Or you may add another attribute. If you use I want to keep the filter over country. If I write all for every single column and I don't include country, every time I add a new column, I have to remember to add this one. So all except makes it easier to say remove from all the columns, but keep the filter here. Okay? Other questions? Yes.
Made up the first of every month. Why did you choose to do that in Power Pivot instead of Power Query, or does it matter?
The question is, when I created first of all, at a certain point, I created a date column here with a calculated column. And first of all, I could have used the virtual relationship like I did for the other dimensions. And it is probably better because actually I'm allocating the entire budget over a single day. However, if it is okay for you to allocate the budget over a single day, you can use a calculated column. You can create the column in the Power Query is the same. Let's say that from a certain point of view, it would be better if I do this in Power Query. In general, try to avoid using calculated columns for very simple calculations. It's more efficient if you prepare the data in advance. If the calculation can be made row by row, please do this in Power Query. It's better. For complex calculation or calculation that involves other tables that you have in the data model, then of course using the calculated column could be better also for the performance. Okay? Question? Okay, I try to repeat the question in a more... So, first, Power Pivot for Excel 2013 has one-to-many relationship, and the relationship only propagates from one-to-many. The relationship can be propagated in the opposite direction in this version of Power Pivot by just putting the name of the table that you have in the calculate statement. I didn't show this here, but it is possible. In the next release of Excel, you can enable the propagation of the relationship in both sides. And this allows you to implement a many-to-many relationship in an automatic way, fundamentally. However, what I did here is this. I created a virtual relationship between, let me see, I have this one here. I created a virtual relationship between this table product and the budget, so for example, from the budget table category here. So I created this. How? By using a filter. Remember, from a logical point of view, a relationship is nothing else than the propagation of a filter from one table to another table. But if I write a calculate and a filter, I can do the same. There is one difference. The physical relationship is faster, yes. But when you apply a filter on a column that has a small number of unique values, it's not bad. And actually can work very well, also because the alternative is to create a more complex data model with more relationships and less features to navigate hierarchies, because a hierarchy requires columns in the same table. And so if you want a hierarchy to navigate category, subcategory, product, you need these columns to be in the same table. Okay? Another question? Yes. Of course, of course. I did a few things in a fast way, but if my budget table had a column that included the year, for example, I would have included the year as a relationship between date and the budget table. If you look at the article, it works exactly in this way. The article has a dynamic allocation using all the relationships in this way. Yeah. The question is, if yes, the answer is yes. The question is, I used this technique here to do the benchmark, but instead of writing sales 2009, I could have wrote sales benchmark, and instead of writing CY 2009, I could have wrote the current year selection. When you do that, remember, since I would have something that works only at the year level, you should do this, SumX date, calendar year. So my formula, including the allocation factor, probably is valid only at the year level. So for each year, I apply this logic again and again. Okay, so this technique is very common. I define a measure. The measure is valid for a certain granularity, for example, the year. I simply iterate over the year, so I'm sure that my entire calculation will be applied only for 1 year. And I don't have to think about how to do this for 2 years. I selected the January in 1 year and December of the previous year. I want to see them together, how it works in this way. Other question? The question is, if you know SQL, would you use a SQL or Power Query? Hard question. If I want to have everything in one Excel file, I would use Power Query. If I'm building a corporate BI system, I would use SQL just because everything is in the center. Last question, then I have to, yeah? I don't understand the question. Probably because it's too long. I don't know. Maybe we can talk here. I just really, it probably is as long answer. Okay, we'll talk here. Okay. Thank you very much. I will be here for a few minutes. Thank you.